Question 11, Part G. The parabola y equals x squared meets the line y equals x plus 2 at the points -1, 1 and 2, 4. Do not prove this. By first sketching the graphs of y equals x squared and y equals x plus 2, shade the region which simultaneously satisfies the two inequalities, y is greater than or equal to x squared and y is greater than or equal to x plus 2. The first step is to sketch both graphs on the same set of axes. So here's our parabola y equals x squared, and here's the line y equals x plus 2. Now the parabola y equals x squared has its vertex at 0, 0, in other words the origin, and it's concave up. And the line y equals x plus 2 has a y-intercept of 2 and an x-intercept of -2, which I haven't shown, but I could do that right now. So I'm just going to put -2 there. Make sure also that the axes are properly labelled and draw the axes with a ruler. So here's the x-axis, here's the y-axis. Now the shaded region contains points that are both on or above the parabola and the line y equals x plus 2. In other words, both conditions have to be satisfied simultaneously. Now because it's both on or above, not just above, the curve itself and the line are drawn using a solid line, not a dashed line. So let's say, for example, the inequalities were y is greater than x squared rather than y is greater than or equal to x squared, in which case the graphs will have to be drawn using a dashed line instead, because that's not part of the inequality or the solution to the inequality. So we're interested in the shaded region that is both on or above the parabola. So that could also include here as well, but it must also be on or above the line. And so here's the shaded region that satisfies simultaneously both of these conditions.